so in this video, we're looking at operations with polynomials, part 2, and we are going to focus on multiplying polynomials. We'll do 4 different examples so you can see all the different ways you could be multiplying. Okay? You only have 2 main skills that you're working on in this video, which is multiply polynomials by distributing and combining like terms, and then writing a polynomial in standard form. We always want our answer in standard form. All right, so multiplying polynomials is basically just the distributive property. Every term in the first polynomial has to be multiplied to every term in the second polynomial. Okay, and that could be any size. It could be 1 term, 2 terms, 3 terms, more terms. As long as everything from the first is multiplied to everything in the second, then your answer is going to be good. Okay, so this first problem, we have a monomial, 1 term, 3x, times 1, 2, 3, a trinomial. So 1 term being multiplied to 3 terms. Okay, so we're going to distribute that 3x to each term, and I like to draw the lines so that I don't lose my place. 3x times 4x squared. So when I multiply these terms together, I'm going to multiply the coefficients and I'm going to multiply the variables. So 3 times 4 is 12. Now what is x to the 1 times x to the 2? If you don't remember, let's review that rule. X to the 1 times x to the 2. Now notice I added the 1 exponent. If it doesn't have an exponent, it's understood to be 1. Okay? So I've got to think about it here. 1x is just an x. But what does it mean to be x squared? That means to multiply to yourself. So 1x is being multiplied to 2 x's, right? X squared is x times x. Okay? So now look at how many x's I'm multiplying. 1, 2, 3. So that's the same as x to the 3rd. So when you are multiplying the base here, sorry, that's supposed to be a 3. When I'm multiplying the base here, I'm actually adding my exponents. Okay? I'm adding my exponents together because that's how many x's are being multiplied. So that becomes a 12x to the 3rd. Now let's go to the next one. 3x times negative 7x. So that's going to be a 3 times negative 7, which is negative 21. And then x times x, think about how many x's are being multiplied. You have 2 x's being multiplied, so that's x squared. And then 3x times 20. So 3 times 20 is 60. Common mistake here is that people will just leave the 60 and forget about the x because there's not an x over here. But there's still 1x being multiplied, so that 1x needs to be there, that x to the 1. Okay? So when you were adding and subtracting terms, no exponents changed because no multiplication was happening. Exponents represent multiplication. But if I'm multiplying, then I should expect some change in my exponents because exponents are representing multiplication. So if I'm changing my multiplication, it's going to change my exponents. Okay? So you should see exponents change when you're multiplying. Let's try another example. So here we have function notation again. If h of x equals 4x plus 11 and g of x equals 2x minus 3, find h of x times g of x. So there's my problem. There's what telling me what I need to do. H of x times g of x, and it's just named it. This is h of x, this is g of x. So I'm going to write it down together. So now we've got to think we have 2 terms times 2 terms. So a binomial times a binomial. So remember what I said, everything in the first polynomial has to multiply to everything in the second polynomial. Before we only had 1 term that had to be multiplied. Now we have 2. And that's okay. Each one's going to take a turn. First, 4x has to be multiplied to 2 terms. Then your 11 is going to be multiplied to the 2 terms. Okay, there he's just going to take a turn. So 4x is going to be multiplied to 2x, and that gives me 8x squared. And then 4x is going to be multiplied to negative 3, which is negative 12x. All right, so 4x was multiplied to both in the second set of parentheses. Now it's 11's turn. 11 needs to multiply to both in the second set of parentheses. So 11 times 2x is 22x. And 11 times negative 3, which is negative 33. Now, do you see any like terms? Yes, we've got an x and an x, okay? And that happens sometimes. You always want to simplify. So negative 12x plus 22x is 10x, a positive 10x. And then we've got our 8x squared and our negative 33. Check to make sure it's in standard form. X squared, x to the 1, and then none. We are in standard form, so our problem is done. A binomial times a binomial is a multiplication that you're going to see a lot this year, okay? It plays into factors, which you'll find out in the following videos. Okay, let's try example 3. So in example 3 is asking to find the product. Product just means multiply. It's the answer to a multiplying problem, okay? So notice we have 2 terms times 1, 2, 3 terms. So a binomial times a trinomial, okay? And that's okay. It's the same process as before. We just have to do it more times. So I'm going to write it out so that I can draw my distributing lines. Okay, now like I said, everything in the first parentheses is multiplied to everything in the second parentheses. So 6x is going to take a turn. It's just now it has to do 3 times. And then negative 1 is going to take a turn. And it'll have to do 3 times. Okay, so here we go. 6x times 10x to the 3rd. And that's going to give me 60x to the 4th. 6x times negative 3x squared. And that's going to give me negative 18x to the 3rd. Think about how many x's are multiplied together. Oops. Hold on. Okay, here we go. 1x times 3x's will give me 4x's. 1x times 2x's will give me 3x's. Okay? And then 6x times 4. And that's going to give me 24x. Okay? Now I want to give you a minute to distribute your negative 1. All right, so negative 1 times 10x to the 3rd, so it should have just changed the sign. Negative 10x to the 3rd. Negative 1 times a negative 3x squared. Again, it's just going to change the sign. And then a negative 1 times 4. Change the sign. All right? So I'm just going to look for like terms, and then I'll be done. So it looks like we have a 60x to the 4th, and that's the only x to the 4th. Now I'm going to look for x to the 3rd. We've got negative 18 and negative 10x to the 3rd here. So negative 18 and negative 10 would be negative 28. We've got an x squared here. We only got one of those. So 3x squared. We've only got one 24x. So only one x. And only one constant. And there we are. Okay. One last problem, and I put this on here because it's one that's missed a lot, because you think it's so simple, but then a lot of people miss the actual answer. So what do you think the answer is if I gave you the problem of the binomial x plus 8 squared? What's the answer? Okay, if you put x squared plus 64, you're really close, but you're actually incorrect. This is a very common answer here because we think, oh, x squared is x and 8 squared is 64. It makes sense, but it's actually not mathematically correct. Go back to what it means to square something. Or if I want to square something, I have to multiply it to itself. So it's not doing x times x and 8 times 8. It's doing x plus 8 times x plus 8. Okay? And now you've got to follow the distributive lines, right? X has to multiply to both. 8 has to multiply to both. So see if you can get a final answer. Okay, let's check. X times x, x squared. X times 8, 8x. 8 times x, 8x. And 8 times 8 is 64. Check for like terms. We've got an 8x and an 8x, which would give us x squared plus 16x plus 64. Now there is a pattern that comes out when you have these squares, but I'm going to let you figure that one out, okay?